Hello friends, welcome back to PharmaHealth Insights. Whether you are attending a GC interview or conducting one, this video will guide you with the right questions and the right approach. In this session, I am going to teach GC like a classroom topic. We are going to treat this like a real interview discussion. I'll ask the questions exactly the way interviewers ask, and I'll guide you on how you should answer clearly, confidently, and practically. So don't worry about theory overload. Just listen, understand, and imagine yourself sitting in the interview room. Alright, let's begin the interview. Now the interviewer looks at your resume, sees GC mentioned there, and asks the very first question. What is gas chromatography? At this point, don't rush your answer. You should answer like this. Gas chromatography is an analytical technique used to separate, identify, and quantify volatile and semi-volatile compounds, where the mobile phase is a gas. This answer works because you clearly mention the word volatile, which is the backbone of GC. When you also connect it with pharmaceutical residual solvent analysis, the interviewer immediately understands that you know where GC is used practically. Now that your basic understanding is clear, the interviewer naturally moves to the next question. What is the principle of gas chromatography? You should answer like this. Gas chromatography works on the principle of partition between the stationary phase and the carrier gas. When the vaporized sample enters the column, different compounds interact differently with the stationary phase. Some compounds move faster, some move slower, and because of this difference, separation takes place. This explanation shows logic, not memorization. So once the principle is clear, the interviewer now becomes interested in applications. So the next question comes naturally. Why is GC used in pharmaceutical industries? You should answer confidently like this. GC is mainly used for residual solvent analysis as per ICH Q3C guideline. During manufacturing, many organic solvents are used and these solvents are volatile in nature. GC provides accurate, sensitive, and regulatory acceptable estimation of these solvents. When you mention ICH Q3C, the interviewer immediately understands that you are aware of compliance requirements also. Now, the interviewer will want to test your analytical comparison knowledge. What is the difference between GC and HPLC? You should answer like this. GC is used for volatile and thermally stable compounds. HPLC is used for non-volatile and thermally unstable compounds. GC uses gas as the mobile phase and separation mainly depends on the temperature, whereas HPLC uses liquid mobile phase and pressure. This clear comparison shows your understanding of analytical technique selection. Now the interviewer will move towards sample related questions. What type of samples are suitable for GC analysis? You should answer like this. Samples suitable for GC must be volatile and thermally stable. Only compounds that can be converted into vapor without decomposition can be analyzed using GC. When you give solvent examples, it shows that you have practical lab exposure. Once you have finished with the samples, now the interviewer will move to the internal parts of GC. What is carrier gas in gas chromatography? You should answer like this. Carrier gas acts as a mobile phase in GC and carries vaporous analytes through the column. Commonly used carrier gases include helium, nitrogen, and hydrogen. If you mention that carrier gas purity should be 99.999%, it creates a strong professional impression. After the carrier gas, now the interviewer will move to the next important concept. What is stationary phase in gas chromatography? You should answer very calmly. The stationary phase is a liquid or polymer coating present inside the GC column. Separation occurs due to differential interaction between analyte molecules and the stationary phase. When you also mention commonly used columns like DB1 or a DB5, it reflects real QC laboratory exposure. At this stage, your GC fundamentals are clearly established. Now, your interview will shift into deeper technical areas, GC columns and injection systems, and that's exactly what we will cover next. What are the type of columns used in gas chromatography? You should answer like this. There are mainly two types of columns used in GC, packed columns and capillary columns. Packed columns are the older types and have larger internal diameters, where capillary columns are narrow bore columns offering better separation. This answer works because you directly address classification first, which the interviewers always expect. Once you mention both types clearly, the interviewer naturally will become curious about how they differ. So the next question will come immediately. What is the difference between packed and capillary column? You should answer like this. Packed columns have larger internal diameter and lower separation efficiency. Capillary columns have very small internal diameter, which allows better interaction between analyte and the stationary phase. Because of this, capillary columns provide sharper peaks, higher resolution, and better sensitivity. This explanation shows that you understand not just the definition but also the performance impact. With this, the interviewer will shift focus on how the samples enters the GC system. And the next question will be, what is the injection system in gas chromatography? You should always answer like this. The injection system is the part of GC where the sample is introduced and immediately vaporized before entering the column. The injector temperature should be sufficiently high to ensure complete vaporization of the sample. If the injector temperature is not optimized, problems like peak tailing or split peaks can occur. This answer reflects practical lab understanding. So once you talk about the injection systems, now the interviewer will naturally ask about the injection modes. What is split and splitless injection? You should answer like this. In split injection, only a portion of the injected sample enters the column and the remaining is vented out. This mode is suitable for high concentration samples. In splitless injection, the entire injected sample enters the column, making it suitable for trace level analysis. In pharmaceutical QC, residual solvents method often use split or splitless mode depending on sensitivity requirements. This explanation shows that you understand the method selection also. After injections, now the interviewer will move to temperature control in GC. So the interviewer will definitely ask you, what's the role of column oven in GC? You should answer like this. The column oven controls the temperature of the GC column, which directly affects separation of compounds. GC can be operated in isothermal mode or temperature programming mode. Temperature program is commonly used in pharmaceutical analysis because it allows proper separation of compounds having different boiling points. This explanation will show to the interviewer your practical GC operation knowledge. Now, the interviewer will move towards detection. What is a detector in gas chromatography? You should always answer like this. A detector is a device that detects compounds as they elute from the GC column and converts their presence into an electrical signal. This signal is then processed and displayed as peaks in the chromatogram. Without a detector, GC analysis cannot be visualized or quantified. At this stage of the interview, the interviewer will become specific and start asking about commonly used detectors. So obviously, the next question which will be coming to you is, what is FID detector and why is it commonly used? You should answer like this. Flame ionization detector works by burning organic compounds in a hydrogen flame. During combustion, ions are produced and the resulting current is proportional to the concentration of the compound. FID is highly sensitive, has wide linear range and provides stable baseline. Because of these advantages, FID is the most commonly used detector for residual solvent analysis in pharmaceutical QC laboratories. At this stage, the interviewer will definitely know that your GC operational knowledge is very strong. Now, the discussion will move towards performance parameters, troubleshooting concepts, and advanced GC applications. So be ready for it, and that is exactly what we will cover next. What is TCD detector in gas chromatography? You should answer like this. Thermal conductivity detector works on the principle of difference in thermal conductivity between the carrier gas and the analyte. When analyte passes through the detector, it changes the thermal conductivity, which is measured as a signal. TCD is considered a universal detector because it can detect almost all compounds. However, its sensitivity is lower compared to an FID. This explanation shows balanced understanding, not just advantages but the limitations also. Now the interviewer would like to know how compounds are identified in GC. So the next question will be, what is the retention time in gas chromatography? You should answer like this. Retention time is the time taken by a compound to travel from the point of injection to the detector. Each compound has a characteristic retention time under fixed chromatographic conditions. By comparing sample retention time with standard, identification of compounds is performed. This will show to the interviewer that you understand how GC identification works practically. After this, the interviewer will move towards chromatographic performance. You will be asked to explain what is resolution and tailing in GC. You should answer like this. Resolution indicates how well two adjacent peaks are separated. Tailing refers to asymmetry of a peak, which can affect accuracy and reproducibility. These parameters are part of system suitability and must be checked before sample analysis. This answer will show your awareness of method performance, not just operational techniques. So friends, once you have answered all above questions confidently, the interviewer will become more practical and ask about problems. You can expect the next question to be, what are the common problems observed in GC analysis? You should answer like this. Common GC problems include no peaks, reduced sensitivity, tailing peaks, baseline noise. These issues can occur due to gas leakage, contaminated injector liner, damaged column, or detector contamination. This answer will show to the interviewer that you have seen GC in real working conditions, not just on paper. So, great going. You have been answering all questions very well till now. Now the interviewer will suddenly shift focus towards GMP responsibility. You will be asked to inform what GMP precautions should be followed during GC analysis. You should answer like this. GC analysis must be performed as per approved SOP. System suitability must be checked before analysis. Instrument usage logbooks, gas purity certificates, calibration records, analytical data, all this must be properly documented. Any abnormal observation must be investigated as per the deviation or incident reporting procedures. This answer will show that you understand quality culture, not just the analysis. Now the interviewer will move towards advanced GC applications. And once we talk about the advanced GC applications, obviously the next question which will be fired towards you will be, what is headspace gas chromatography? Your answer should be like this. Headspace GC is a technique in which only the vapor phase present above the sample is injected into the GC system. The actual sample matrix is not injected directly. This helps in minimizing interference and protects the GC column. This explanation will immediately show your advanced GC knowledge. Now it's time to test your deeper understanding. So the next question will be, what is the principle and advantage of Headspace GC? You should answer like this. Headspace GC works on the principle of partition equilibrium between the sample matrix and the vapor phase. Only volatile components enter the gas phase, while non-volatile components remain in the sample itself. Because of this, Headspace GC provides cleaner chromatograms, better reproducibility, and longer column life. This answer will clearly reflect your strong analytical maturity. I'm sure, friends, at this point the interviewer will 100% be satisfied with you. So, if you have reached till here, let me tell you something very honestly. You don't just know gas chromatography anymore. You now know how to speak GC in interviews. You know what to say, how to say, and when to say it. Remember one thing, interviews are not about answering everything, they are about answering correctly and confidently. So friends, in this video we covered GC concepts, applications, GMP expectations and headspace analysis. Now let's move on to what's next. There is one area that truly separates average analysts from strong analysts, and that is troubleshooting. In the next video, we will go deep into GC troubleshooting made easy. No peaks, poor sensitivity, baseline noise, tailing peaks, gas leakage problems, real pharma lab solutions. That video will be purely practical and experience based. So stay connected with Pharma Health Insights because knowledge gives confidence and confidence clears interviews. So friends, thank you for watching. If this session added value to your learning, don't forget to like, share and subscribe for more practical industry solutions. Till then, this is Rajesh signing off.